This is pre-AP Precalculus. On free response practice number 41, you cannot use a calculator. Answer the following questions about trig identities. Be sure to show every step of your work. A, show that the expression secant of theta times cosecant of theta minus tangent can be simplified to cotangent of theta. Well, I'm going to take this equation, I'm going to first change it to be in terms of sine and cosine, because in the past that has been a great strategy. Secant is the same as 1 over cosine of theta. Cosecant is the same as 1 over sine of theta. And tangent is the same as sine of theta over cosine of theta. So I just used 3 trig identities. Now that I have these two fractions, I'm going to subtract them. And to do that, I need common denominators. This fraction needs a sine of theta on the bottom. If you multiply it times the bottom, you got to multiply it by the top, because essentially that means we're multiplying this by 1. That's going to give us 1 minus sine squared of theta over sine of theta cosine of theta. Just to remind you, when you subtract fractions, you subtract the numerators, leave the denominators the same. Now I recognize that 1 minus sine squared of theta is cosine squared of theta. Let me give you a little bit of an explanation for that. Sine squared of theta plus cosine squared of theta is 1. That was our first Pythagorean identity. If we subtract sine squared of theta from both sides, we're going to get cosine squared of theta equals 1 minus sine squared of theta, which is how I was able to take this in the problem and replace it with cosine squared. Now this fraction that I have, I can reduce it because I can divide both the numerator and denominator by cosine. That leaves me with cosine of theta over sine of theta. That's a trig identity. That's equal to cotangent of theta. Part A said that showed that can be simplified to cotangent of theta. We've just done that. This thing I had written over here on the side is the side work. Side work isn't always optional, but that specific side work is, because we use that all the time. B, show that this expression can be simplified to cosecant of theta. Well, I'm just going to go with the old tried and true method of changing everything in terms of sine and cosine. Secant of theta is going to be 1 over cosine of theta. Cosecant of theta can be changed to 1 over sine of theta. Tangent of theta can be changed to sine of theta over cosine of theta. Since I want common denominators in my denominator, I'm going to change 1 to cosine of theta over cosine of theta. I also want common denominators in my numerator, so I'm going to multiply this first fraction times 1 in the form of sine over sine, and the second one by 1 in the form of cosine of theta over cosine of theta. So my numerator, I'm going to end up with sine of theta plus cosine of theta divided by sine of theta times cosine of theta. My denominator is going to give me cosine of theta plus sine of theta over cosine of theta. Now this is a complex fraction. I don't want it to be complex. I would like to get rid of both this denominator and this denominator. To do so, I'm going to multiply this by 1 in the form of sine of theta over sine of theta, and also by cosine of theta over cosine of theta. That eliminates those sines and cosines. It eliminates this cosine. So what's left is going to be sine of theta plus cosine of theta in my numerator. And my denominator is going to be cosine of theta plus sine of theta times sine of theta. Now we can cancel a sine of theta plus cosine of theta from the top and the bottom, because essentially the top is being multiplied by 1, the bottom is being multiplied by sine. We end up with 1 over sine of theta. That, of course, is cosecant of theta. We've done what we were supposed to do. We're supposed to simplify to cosecant of theta. Finished. Part C. Verify that this is an identity. The left and right sides have to be equal. When I do these problems, I like to start with the left. When I say left, I mean the more complicated side. This problem, it happens to be the left. Let's see, I'm going to choose to not get everything in terms of sine and cosine initially. I'm going to add these two fractions together. To do that, I'm going to multiply the fraction on the right by 1 in the form of tangent over tangent of theta. Fraction on the left by secant of theta plus 1 over secant of theta plus 1. Here's what that does for me. Gives me a denominator of a secant of theta plus 1 times tangent of theta. In my numerator, I have a secant of theta plus 1 times the secant of theta minus 1 plus a tangent of theta times the tangent of theta. I'm going to simplify the numerator, but I'm going to leave the denominator the same, because a lot of times the denominator we don't need to do much with. I may change my mind when we get to the end. We'll see what happens. Multiplying two conjugates, two binomials with different signs between them, will always be the first term squared minus the second term squared, and 1 squared is 1. That's the same as what's in red up there. Tangent times tangent is the same as tangent squared, theta. Now the top, I can see there's some Pythagorean identities in this. We have a secant squared of theta, which is one of the Pythagorean identities. And we also have a tangent squared of theta, which is in one of the Pythagorean identities. I'm going to replace secant of theta with tangent squared of theta plus 1, because that was the second Pythagorean identity. I'm replacing that with this. The parentheses have no mathematical value here. I'm just putting it for emphasis that that is what I substituted. Now my numerator can be simplified. We have a plus 1 and a minus 1. If you add those, you get 0. We have a plus tangent squared and a plus tangent squared. If you add that, you're going to get 2 tangent squared of theta. Now the reason that's pretty exciting for me, the right side of the equation had this 2 all along. I didn't know how I was going to get it, but we just got it. At the bottom, we got secant of theta plus 1 times tangent of theta. Now I can cancel a tangent from the top and the bottom. And now we're going to have 2 times tangent of theta over secant of theta plus 1. Now we are supposed to simplify it until we get 2 times sine on the top and 1 plus cosine on the bottom. We do not appear to be close to that. The one thing that we do have is this 2. So now I'm going to change everything in terms of sine and cosine. So I'm going to have 2 times sine of theta over cosine of theta divided by. I'm going to change secant of theta to 1 over cosine of theta. And I'm going to change 1 to cosine of theta over cosine of theta. Why? So I have common denominators down here. Whoops. That's going to give me 2 times sine of theta cosine of theta divided by 1 plus cosine of theta over cosine of theta. Now I'm getting pretty excited because I have a 2, which the right side has, I have a sine, which the right side has. I have a 1 plus cosine of theta, which the right side has. To get rid of the cosines that we don't want, I'm going to multiply by 1 in the form of cosine of theta over cosine of theta. If I do that, those cancel and those cancel. So what are we left with? 2 sine of theta divided by 1 plus cosine of theta. And if I remember correctly, that's what the right side was all along, which makes us finish with this. Excellent.